In the topic of conduction in semiconductor, first we have to learn some of the terms. In that, the first one is the charge mobility. So, the name itself tells you what is meant by charge mobility. So, it is the movement of the charges, either holes or the electrons. So, it is also known as drift mobility. And mobility of the electrons or the holes is defined as the average drift velocity acquired by the electron per unit electric field. So, when we apply an electric field, then the electrons or the holes will move. So that mobility is represented as charge mobility mu. So here they have explained, when electric field E is applied across a piece of material, the electrons respond by moving with the average velocity. So when a semiconductor is applied with an electric field, electric field is nothing but connecting a battery, so then the electrons or the holes will move. So that is known as the charge mobility, and it is defined as drift velocity per unit electric field. And we already know that drift velocity is represented with the meter square per second and electric field is represented with the volt. So the units are meter square per volt second. In centimeters, centimeter square per volt second. So here, the drift velocity is nothing but when electric field is applied across a piece of material, the electrons respond by moving with an average velocity. So when we are applying an electric field, so the electrons will move with an velocity that is known as drift velocity. Vd is equal to mu e. So here it is the proportionality constant when Vd is directly proportional to electric field. If the electric field is more, then the drift velocity will be more, and that is replaced with a constant that is mu. Here the electron mobility is greater than the hole mobility. So this we already seen in the differences, that is 1300 square centimeters square by volt second, and it is 500 centimeters square volt second. These values are for silicon and this will be different for the germanium. So that is about charge mobility. In our next video, let us see what is meant by conduction and current density and their relationship.